The end of the last episode was embarrassing.
Yeah, we need to find something to fix that.
But we learned.
Yeah.
We learned. We checked out the documentation, we checked out some GitHub issues, and we discovered that, yes, the documentation was wrong. Yeah, we'll fix that in the future probably, but for now, and by fixing, I mean sending a pull request to the authors of Javalin. But for now, we learned what we need to do. We need to say app.event, and then we need to say what kind of event we are listening for.
That's Javalin server stopped.
Server stopped. We want to run this after the server is completely stopped.
Yeah, and then you want to close the connection.
And only then I want to close the connection.
Yeah, that's it.
That's it, really. And the problem was that the server was closing the connection to the database before the thing
actually started.
Yeah, and then we were trying to get a statement and we couldn't. So now if we rerun the server, everything should work. What is this? I have no idea. We may have been doing other things off camera. But that's, not what we want to run.
That's bad.
No big deal, really. Come here and run this. There you go. So now the server is running. Let's go to the app.
And there you have it. You have
Sounds good. I can click on plus.
Looks fine.
It's creating new items.
Yes.
There is one thing I want to change. And now that we know how to work with the life cycle of the server, we can run some code when the server starts.
Also,
We also know how to run some code when the server is starting. And this is something we would like to do when the server is starting. So creating this connection to the database is something that we do even before the server has even a chance of thinking about starting. But this, this works. It's okay, but it would be better if we could tell, this is the kind of thing you want to run when the server is starting
up. Actually, it's one of the first processes that you should run so that the application works.
So we can use the same event thing, but now we go to a different kind of event that is server starting. And just as a reminder, this syntax means a block of code with some argument, except that I don't need an argument really, so I can leave this as an empty list of arguments. But I still don't want this to be that. That is a block of code without even the chance of having an argument. It's not even a proper syntax in Java. So I want this to be an empty list of arguments to this block of code that will run when the server is starting. And then I can say this part of the code when the server is starting. Now that I did this, I can come here to these guys and rename them, because they will no longer clash with this. And that's the whole reason why I wanted that block with server starting. It may also be a good idea to put all the events together. So now we know the whole life cycle of the server, when it's starting, when it has stopped, and the API requests, and then where to find the JavaScript and HTML. And then finally, as the last thing, we start the server. Let's rename these guys so that we can show how to refactor things in IntelliJ. There's this rename refactoring. And we can rename this to just plain statement. And it renames not only the variable definition, but all its uses as well. Same here for create statement. I learned that the shortcut is Shift F6. And then we can rename this to statement.
That's it.
And now all the things look the same. Create a statement, execute something, close the statement. Create a statement, execute something, close the statement. And if you have a result set, close that as well. Sounds good to me.
Looks standard.
And then let's just rerun this to make sure I didn't break anything, but I suppose I didn't, because I just reordered and changed some variable names, but refresh, add some items, looks good. Now we can go to the main topic of this episode. Testing. Why? Why do we want to test?
Because I don't want to push buggy code on the server, like on a production server. I don't want, Okay, I'll put it this way. I know of a story of someone in Microsoft, like my friend told me, and some guy made a very simple error, like a stupid error almost in operations, uh, and the code was pushed to production. Somehow it went through code review. They lost 10 hours of manpower and around $150,000 just because of that, and the guy was fired.
So you want to keep your job. That's why you want to write tests. Yeah.
That's good incentive.
The way I see it is I don't want to have to come here to the interface and click on plus every time I want to see if my application is working. Especially as my application grows, there will be a ton of buttons for me to click.
This is simple. This is like you can manage clicking one button 50 times. But if you have like 500 different things, you're screwed.
So what I want is to have a computer program that tests my application. A computer program to test my computer program. And that will be automatic.
Going levels.
And there are different levels of testing. Coming here to the application and clicking on plus is one level of testing. It's manual testing, but it's still testing. There are some automated tests in different levels as well. So there are automated tests that go to the simplest thing, the smallest thing, like one method in one class in Java, and test just that. There are tests that try to test a whole request. So in Postman, you can write tests. You can see here in Postman this thing called tests. So you can write a test for a whole request, a whole API endpoint.
See what the result is returned or what response is returned or if it's correct or not.
We will start with the simplest kind of test, unit test. A unit test is the one I mentioned before.
It's tests in isolation, basically.
Just one method or one class, the simplest unit of code. Unfortunately, in our app, we don't have a lot of logic to test. We don't have much to test here. So this item, in Javalin, I would write tests for things like this, whole API endpoints. But since we want to work with the simplest kind of test, the unit test, we'll have to test the item, which doesn't do much. It's only a data class. It only holds the identifier and description.
So how about you just check if the values are correct?
So we'll write
I can't think of anything else.
It's somewhat artificial to write this test, but it shows how to write a test. And when we have
the process of setting up JUnit, which is a big deal.
And when later we have more logic in this, like suppose that you can have an item in different degrees of completion, something like
work
that.
In progress
or you can assign the item to someone else, that sort of thing. We could start to write more meaningful tests.
I have a feeling we were picking up stuff from GitHub issue pages, like assigning to people and reviewing and
adding labels.
Stuff. Literally what that page does.
Anyway, so we will write some tests for the getters and setters. Not the kind of test you would really write
for actual applications, but it's a
for the sake of demonstration.
Let's do that.
So let's bring JUnit into our project. JUnit is the framework, the library we use to write tests. Let's go here to Gradle because that's where we add all our
package dependencies or stuff like that.
And we can see that JUnit is already here because when we created the project, IntelliJ started with a Gradle file that included this line. But I don't like this line because this is an old version of JUnit. We want to use the latest and greatest always, so let's use JUnit 5.
Latest and greatest.
So we come here to the JUnit 5 thing. That is our testing framework in our toolbox. This is the toolbox page you know and love. So here, the JUnit 5. Let's go to the user guide. This is where you come to learn about JUnit, how to write tests and everything. But I want to know how to get started. And there is some example projects for Gradle and Java. That's
perfect for us.
What we are using. In this, we can come to their build.gradle
and see what's up.
And they have some things here. And I want to borrow something. Well, for one thing, I want this plugin for IntelliJ. I don't know exactly what it does, but if it's for IntelliJ, I'm using IntelliJ, I want it. The repositories we already have, it's here. And the dependencies, well, we can just copy this line and
replace ours.
Replace this line with that one.
Yep.
Also, this is
a whole new
instructing Gradle to use JUnit to run the
Yes.
tests. So I want this as well.
Yep, that's about right.
Perfect.
It should index.
Now IntelliJ did its thing already,
Yes.
and we are ready to write some tests. And the tests go into, let me delete some things that we created before. Okay, so the tests go into source tests.
Yeah, in Java, yeah.
In Java. And the convention is that you create a
Use
package.
the same package name. Yep.
The same package name to create the tests for that package.
Yes.
Why? Well, because there are some accessibility things.
Yeah.
If your class is not public, in our case, our class is a public class. But
so
if your
you
class
can access it using different packages, but if it's private, you need the same package name.
If it's private, I don't think you can even do that with the same package name.
Yeah,
but if you just use it like this, then
there's
it's
a what do you call
the full package.
Yes,
the full accessibility thing is a package.
Yeah, I think
accessibility.
That's what, like it's called something very particularly that I can't recall. Right? That's it.
So yeah, just for following the convention, we will create a package here. And we'll call it the same as this one. So con JUnit TODOOSE.
That's all you want.
And then we can create a class to test our item. So a new Java class that we'll call
item tests.
Item tests. Yes. And here, well, let's go back to the user guide for JUnit. Writing tests. First, we want to import this assertion thing.
Yeah. Here it just means that you can use assert equals in the file, which we want to do because our test is like really simple.
Yeah. So let's create a test. A test is a method that has this annotation.
Yeah.
Oops. So we want to create a method. Let's call it, it doesn't return anything. Let's call it test getters and setters. Yeah. I like the names to be descriptive because if the test fails, then we see a descriptive name. Yeah. And then we can say assert equals. Why? Because I imported static. So it's coming from JUnit, and I don't have to put any prefix like assertions, or I could probably assertions.assert equals, but that would be annoying. You would have to import that class, and you would have to say assertions dot every time. I don't want to do that. So I just import static. Yep. And I can assert equals that 5 is equal to 4. Just to see how this works, okay?
Sure.
Also, as I said, you have to say that this is a test. Yes. Now I can come here and run all the tests. And the test fails. There were failing tests. Let's see what test failed. Well, this one. Yeah. Excellent. Double click. This is the assertion that failed. Expected 5, but was 4. Yeah. So if I say 5, 5,
it should work.
And we run, now it passes.
Yep.
Excellent. If you don't see a list of all the tests that are passing, you click on this button here, and then you see a list of all the tests that are passing. All the tests passed. Perfect. Now let's actually test our application. We can create an item.
A fake item. I think we do a lot with fake data.
Yeah. And it expects the identifier and a description. And then we can test that 5 is the item.get identifier. And similarly for the description, I expect to see these when I get description.
Yes.
Rerun.
Yes.
All the tests are passing.
That's good.
Yep. So we know how to set up JUnit, and we know how to test.
Actually, a point to make here is that here it's not actually, when I run test here, it's not actually starting the server to do it. It's creating a simulation of it and then running that test and telling us if it's correct.
Yeah, well, in this case, it's not even simulating the server. It's not doing anything because when we run the tests, this method, the public static void main, doesn't run.
Yep, exactly.
So we have access to the server, and we could say in our test here, we could, and let's try server.name. And
It starts the server also.
Main cannot be applied? I don't know. Can you
think
try to
you
fix
need-
this? We
no,
create
no,
method
no, no.
main in server?
No, you need to put in a parameter, don't you?
Oh, yeah.
String.
So you have to give it an array, and I think this is how you write an array.
Oh.
Array initialize is not
You
allowed
have to
here.
have it outside.
I want to create an array of strings, right?
Yeah, so I'm saying that it has to be done before you actually pass it. It can't be dynamic initialization.
So I can say var strings equals an array and then say strings.
Yeah.
Array initializer is not allowed here. I don't know how to create an array in Java. I have absolutely no idea.
Square brackets?
String
like
array, if I am explicit, then it works. And this may throw an exception.
Yeah, because it has
SQL
a try
exception,
catch, yeah.
This exception. So add exception to method signature. And now if I run this will start the server and it will never stop the server.
Yes.
And this will even fail. Why? Address already in use. Okay, that's just because there is already a server running. Again. Yeah, so see, it's super interesting. It tries to start the server.
Yeah.
But then the tests pass. I have no idea how the server is not hanging forever and making the test fail. It's supposed to, I guess. But in any case, the point here is that, yeah, without these lines that are artificial and bad, and we shouldn't have them here, without these lines, this test never really starts the server.
Yes.
We are just running the tests against the units. In this case, the unit being this class.
Yep.
Fine. Okay. I think I'm happy with all of this. We have an application that works. We have automated tests.
We'll do continuous integration next time?
Maybe.
Maybe deployment?
Yeah, I think that may be a good idea. We could go to those other parts of the infrastructure. And then we will come back and revisit the whole stack because we still need more features in the app. So before I commit, I want to clean up some things. We have some imports that are not being used. So I think there is a shortcut. Yes, it's Control-Option-O that cleans all the imports that are not being used. And the same thing in server. There are some imports here from other things we tried in the past. So Control-Option-O got rid of those imports. And with that, I'm ready to commit.
We screwed up again.
Why?
With Git.
Why?
Should have committed when we ended database.
The problem is that in the previous episode, when we ended database, we didn't leave the application in a working state.
That's correct. But when we did...
So are we on a branch?
Yes.
I forget. What is the branch called? It's called database. Fair. We are still working on the database, more or less. We are also working on tests.
Pushing the boundaries, but okay, we can do it.
So commit.
Check
what do we want to commit? Well, I want to commit the changes in Gradle. Yeah, I do. The changes in the server.
Yes.
Uh-huh.
That's the whole logic behind
databases.
Getting post now, yeah.
Yes, fair. And also the tests.
Yes.
So now use the database and add some tests.
Okay.
Commit and push. Push, yes, sir. Go to GitHub. Go to our repository in JUnit, TODOOSE.
Yes. See, there should be something.
The pull request is still a work in progress. Well, not quite. I think now it's ready.
Remove that and merge it.
Ready to be reviewed.
Okay.
No other labels. Yeah, we removed the work in progress label. I think we forgot to do that in the other pull requests that had the work in progress label. Yeah. But in any case, now the thing is ready for review. Let's see what changed. We have
a useful get ignore.
Yeah, we are now ignoring the database. The database file created by SQLite. We added IntelliJ. We added
stuff to the Gradle, yeah.
Yeah, we added JUnit to the project, including to IntelliJ. We have changed a bunch of code, a lot of code really. This one looks good to me.
Yeah, we can merge.
I wish I could say accept or approve to myself. They can't. So, pull request,
Done.
merge, confirm merge, delete branch, go to IntelliJ, branches. I bet there is a more straightforward way of doing this.
Yeah, actually.
Checkout, pull, get rid of that branch. The database branch, delete.
And that's that.
Okay, all right. We are good for this one.
Yeah.
I see you on the next one.
Yeah.